Hello everyone, this is Brad again with Oomlout's Experimenter's Guide for Arduino Project 2. This is 8 LED fun, multiple LEDs. Now, as you can see here, the circuit is set up with pins 2 through 9 connected to 8 different LEDs. The ground portion of the LED are buffered with 560 ohm resistors all the way down, and we have power and ground run to the power and ground pins over here. Now, we don't necessarily need power for this circuit because power is being supplied through pins 2 through 9, but it's just a good habit to have that there just in case. And when the circuits become more difficult, we will be using the power. So, this is the basic circuit. As seen here, it lights up one LED, delays, lights the next, delay, lights the next, and cycles all the way through till the end, and then turns them all off. Down to this one, turns off all of them, and then loops back around. And we'll go see the code. So this code is available from this website here, ardx.org/code, and it just shows up in your browser like so. And first, we'll go through the code. First here we have the first setup. We're setting this variable LED pins as integer array, which is what these square brackets denote, and this is pin 2 through 9. Now we go down to the setup. And this setup is designed to run a for loop, and what it does here is sets each of these spaces, so there's 8 spaces, 0, 1, 2, 3, 4, 5, 6, and 7, and it sets each of those to a value. These are the pins, but for the coding, as we go down here, we'll set each value or space in that array and use that variable to turn each pin on or off. So this for loop starts at I equals 0, which is pin 2 space 0 in this array, and sets that as output 1, and this loop repeats 8 times. So first time it starts at I equals 0, and then it goes to the next one up in the series. I plus plus means that this loop is counting up in the variable I. So I equals 1 is the next one, and it sets that as an output. And then I equals 2 sets in an output, and it goes to all values from 0 to less than 8, so 0 to 7, which is space 0 to 7, and that sets all pins to an output. And as we can see here, this is commented out, but this is what you would have to type out if you didn't want to use a loop. So each one, pin mode, LED pin 0, output, LED pin 1, output. So basically this loop up here is doing all of this just in a loop, so you save 6 lines of code or so there. Now that once we've got all the pins set up as outputs, we go to the first loop here, And we're calling this first loop that they've set up for us one after another no loop. And what this does is basically loops each LED on. It turns them all on, but this first one on first, then it delays for a time of 100 milliseconds, and then goes to the next pin, turns that on, delays again, turns the next one on, delays again, until they're all on. And you remember high is pulling the digital output to plus 5 volts. And once it turns them all on, it just continues on to the next part of the code, which is to turn 7 off, and when you pull a digital pin low, it pulls it to 0 volts, and then delay again for 1/10 of a second, pin 6 off, delay all the way until it's off. And then, since this is a loop, there's the start of the curly bracket there, and then the end of the loop is here. So when it hits this, the last delay, it goes right back to this first one and then turns pin 0. Okay, now that we've completed the basic code, we'll move on to the making it better section. And the first part of that is to explore the different loop functions that they've given us in this example, and there's 4 of them, and they are in this main void loop. We just looked at one after another no loop, and now we'll be looking one after another loop. Now to initialize these, you just delete these 2 forward slashes and recomment out the one you don't want. So I've just deleted the 2 for this loop and commented out the first loop, and so it'll be running that loop, and that loop is next down here. And again, we're going to be using a 1/10 of a second delay, and for this loop we've then condensed these 2 huge chunks of code into just 2 sections, turning LED ons and turning them off in sequence. And just like the setup loop, we use the for loop, and we'll be starting at I equals 0, which is the first space, pin 2, and counting up, I++, counting up to I equals 7. And each time it hits that one, it hits the space of that array, it'll be writing that pin to high. And then it delays, and this is the end of the for loop here. It delays and then goes right back to, counts up to the next one, so I equals 1, LED pin 1 high, delay, and basically you get exactly the same as you did with the other one, just condensed. And then again here, down, we'll start at pin 7, counting down, I minus minus, down to 0, and each time, once it hits 7, we count backwards and turns them all off, so it pulls them low. So less typing saves lines of code in long lines. And now we'll look at the next one. Okay, this is the third loop of the 4 that we were given in examples. This one is called one at a time, and this turns on one LED, turns on the next one, and at the same time it turns on the next one, turns off the previous one, and basically just loops in sequence again. So that loop is down here, and again we're starting typing out this loop, delay time again 1/10 of a second, and this time now, since we're turning off the previous LED once this next one is turned on, we start out again counting from 0 to 7, and we're now bringing in a new variable off LED. And what this is now going to allow us to do is put in this off command, so to turn the LED off. And what you need to do, or what it does here, is this variable is stored as the previous space in the array. So to do that, the space that it is currently on in the loop counting, it will take that space and subtract 1. So for instance, on space 3, which would be pin 5, it would then take I, which is 3, minus 1, which would be 2, which then stores this as 2, and then when it goes down here, when this on is on space 3, it will then read 2 in this, which pulls that to 0, so it turns off the previous pin. And since, well, we also include this if statement here, since I has a value of 0 as well as 1 through 7, 0 minus 1 is -1, and since there's no -1 space in that array, we have to then define that one instance to be 7. So if I is equal to 0, this doesn't, you want to use 2 equals there, because that is a true or false. If you had 1 equals, it would just change I equal to 0 and it would kill the code. So if the idea is if I equals 0, if this statement is true, then start that, and that changes it to 7. So that then turns off the previous one, and this one doesn't cycle to 7 to LED 8 and then 7 6 5 4 3 2. It just goes from 0 to 7, and then once it hits 1, I equals 1, so it'll hit all the way up to I equals 7 and then turn off 6, and then once it goes back to 0, it turns off 7, but it turns on 0. So we're going 0 1 2 3 4 5 6 7 and then back to 0, and that looks like this. Okay, and here's the fourth loop that we'll be looking at in the Making It Better section. As you can see, the lights go from end to end and meet in the center. Now here is the code. And as we can see, void in and out is the name of the loop. Time delay still 1/10 of a second. We use a similar counting method to set up the values of I for the different spaces in the array. This one, basically there's two parts to this code. This first part here deals with running the LEDs out from the center, and then the second half goes from the outside and back into the center. And this will run, and then it connects and runs this, and then loops back. So this void, the in and out, is all one loop. This first section, counting from 0 to 3, which is starts at pin 2, goes to pin 5, and then we also have the off LED from the last variable from the last one, and that sets I as the previous pin, and then we can use this variable anytime we need to see what the previous pin was. And then also, just like the last loop we looked at, we have to set this I equals 0 scenario so that it circles back around, and when I is in the 0 setting, off LED equals 3, so we don't get a I equals -1 issue. Now we look down here, these digital writes are the functions that we're using to turn on and off the LEDs, and pulling high, again with the digital output, is 5 volts, and pulling low is 0. Then we use these on LED 1, 2, off LED 1, 2 variables to control which ones go on and off at using this counting sequence here that we first came up with. And on LED 1 is the first to go on, and then LED 2 is the mirror image of that. So when I is 0, 3 will turn on and 4 will turn on, which is what, and you get that the first 2 center LEDs to go on at the same time. And then as I counts up to next to I equals 1, number 2, LED 2 will go on, so the first LED will go up, and then this one changes to 5, which means the next one down will also be on, so now they're spaced 2 dead LEDs apart, and that continues. And this is also the off LED. These 2 here will then turn the previous LEDs off. And then once the light reaches the ends 0 and 7 LEDs, then it pauses for a tenth of a second and then goes directly to this portion of the code. And this is basically exactly the same, except the count goes from 3 down to 0 in steps of 1 down from 3. Same code and everything else. Right, and for the last portion, we were tasked with coming up with our own animation. Mine is designed around something I've been trying to figure out with Arduino on coming up with a data acquisition system for a Formula race car team for a college senior project. And this is a sequence I came up with that is basically an LED test sequence to, at the start, every time the vehicle started up, it runs this sequence to test all the LEDs, make sure one's not burnt out and that they're all working correctly. So you can see it flashes twice and then runs up all the way with all LEDs lit, and then cycles again one last time, just one LED at a time, all the way from the right. Alright, here's the code. Basically the same setup as the original animations. I just basically combined a couple of them, changed some of the timings, changed some of the counting techniques and then put it all into one. So again, same variables, same setup, sets it all pins as outputs. These are my delay times throughout. This first section here is blink first and blink second. And basically I just took the code from this turn each LED on one after the other, and basically turned the delay at the end of that code down to 0, so it still cycles all the way up and back, but the delay is as fast as the board can process it, so it looks like a blink. And I have 2 blinks and then a delay, then the next portion of code comes on, and that's when the board turns on all of them, each LED at a time to the right, and then all off, each LED to the left. And that's the same as the last code, just changed the delay time a little bit. And then this one is the ending portion, the cycle one at a time. And I edited code from the last portion of this, or the second to last portion of this, where the mirror image lights went from the middle to outside, and basically just changed it so it went all the way down and then came all the way back. And then this last portion, there's a light. The LED 0 stays on at the end of this code, so I just turned it so it turned off, and then it delays for 3 seconds and then loops back around.